Good morning. My name is Brady Mangrum, and for my AP research project this year, I studied the prime number problem. So, what is known? We know that a prime number is any integer that has only two factors, which are 1 in itself. We also know that the average distribution or distance between prime numbers gets larger as the size of these primes increases. What is not known? We do not know exactly why prime number distribution tends to be so random. What is being researched? Mathematicians are researching ways to better understand prime number distribution and its nature. The end goal for this research is to accurately and reliably predict larger new primes. For my cornerstone papers, the paper Are Prime Numbers Special was one of the most used papers in this study. It covers the nature of prime numbers and where they tend to show up in the real world. The paper Patterns Everywhere was also used throughout this research. This paper gives evidence to suggest that patterns appear in math and in the real world frequently. This means that more likely than not, there is some sort of pattern to be found in prime numbers. The paper Is Mathematics Discovered or Invented discusses, coincidentally enough, whether or not mathematics is discovered or invented. It argues that it is indeed something that is discovered. Math is part of the language that the world around us is deciphered through. It is how we make sense of our world. For example, physics uses math to understand the laws of nature. We are not done discovering new things in math because we are not done discovering new things in our world. This leads me to my research question. Is it possible to more accurately describe prime number distribution? This is an interesting question because it was not my original thought when approaching my research question at the beginning of this year. My original thought assumed the answer to this question was yes, and rather questioned if imaginary numbers were the key to more accurately describing prime number distribution. However, the question, is it possible to more accurately describe prime number distribution, is important to be answered first. For my method, I used grounded theory. The definition of grounded theory is a methodology which is characterized by the iterative process and the interrelatedness of planning, data collection, data analysis, and theory development. Essentially, grounded theory is the formulation of a new theory that is rooted in already agreed upon theories in the math realm. The process. For step 1, my initial approach for my process is to gather a list of the first 1,000 prime numbers. Step 2 is to take that list and graph it on a standard XY coordinate plane. Step 3 is to graph the equation for prime number distribution theory on that same plane. After that, use statistical analysis to determine the R squared, which is the coefficient of determination. This will allow me to determine which function is closer to the scatter plot, that is the 1,000 prime numbers that were graphed. Step 5 is to test different alterations to the prime number distribution theorem. After that, put it against the prime number distribution theorem and the actual graph of prime numbers and determine the new R squared for this equation. If the R squared does not increase from the original, then repeat steps 1 through 6, except make different alterations to possibly bring it closer. Findings and analysis. The top line on this graph is actually a scatter plot of 1,000 points. Each of these represents how many prime numbers there are at or below that number. For example, at the point 2,350, there are approximately 350 prime numbers at or less than the value 2,000. The line underneath these points is the prime number distribution theorem line. The function for this line is f of x equals x over natural log of x. As you can see, as the numbers get larger, this function becomes less and less accurate. The r squared for this function I calculated to be 0.9502. After some adjusting to the original function, I landed on this function. F of x equals a times x over the natural log of x plus 10 times 1/3, or 10 sine times 1/3 of x. And when you zoom in, this is what this new function looks like. In the program I used, a in this function is just a constant factor that the computer manipulates to bring the function closer to the scatter plot. The number the computer gave me for this was 1.12515. The 10 represents the amplitude, and the 1/3 represents the period, which is the side to side. The r squared for this function I calculated to be 0.9991. This coefficient of determination is considerably higher than that of the original, which was 0.9502. This is a distribution graph. Each point on this graph represents a gap between prime numbers. For example, the gap between 5 and 7 would be shown as a point at the value 2. The range for the first 1,000 primes typically remains between 2 and 30. There are some outliers like the gap of 1 between 2 and 3 and the one gap of 78, which you can see right here. The average size of these gaps gets larger as prime numbers get larger. Limitations. As I briefly mentioned earlier, my original plan when conducting this research was to determine whether or not prime number distribution had a relationship with imaginary numbers. Unfortunately, though, either there was not a graphing program or there wasn't one available to me that could do what was necessary to go through with this original plan. I also had struggles early on with finding an expert advisor, which might have been able to help me find a program that could have worked in the way that I imagined. Time. If there was more time available, it is possible that a program that functions this way could have been found or even created. But with the time frame available for this study, this was not feasible. Another limitation is that my data set is only for the first 1,000 prime numbers. There was simply not enough time to do more than 1,000, considering I had to graph all of them manually. Reflection and conclusions. In conclusion, although the study did not necessarily prove anything, it has shown that in theory it is possible to more accurately and reliably describe prime number distribution since a function was found that had a higher coefficient of determination for the first 1,000 prime numbers. One of the implications of these findings is the potential opportunity for whole new fields of mathematics. In math, when something new is discovered, doors start to open in unexpected places and new forms of math start to show up. Another implication is the need for change in cybersecurity. This is because some cybersecurity uses the random nature of prime numbers. If prime numbers were suddenly predictable, it could cause major problems in the tech and cybersecurity world. Future directions. In the future, researchers could use this study to help them find a better way to describe prime number distribution for more than just the first 1,000 prime numbers. In the long term, researchers might be able to accurately predict larger new prime numbers. This is my bibliography. Thank you.
Brady, thank you so much. All right, oral defense panel, question number 1. Brady, how did the choices you made when designing or implementing your research method impact your research process?
So my method is grounded theory, and it's a lot different. Nobody else this year in our class chose grounded theory for their method. And the reason for that is because it's primarily a method used in mathematics research. Because in mathematics, you're not really running an experiment per se. You are testing a hypothesis, and if it doesn't work, you try something else, and if it doesn't work, you try something else. You basically use theories, like I explained earlier, that other mathematicians agree upon, and then try to build a new theory off of those. And so that directly impacted my process for my research, because it was essentially a test. If it works, great. If it doesn't work, rinse and repeat.
Brady, what are the real-world implications or consequences related to your findings?
So some of the implications related to my findings, like I said earlier, are new versions, new different kinds of math could show up. Like, for example, we've had algebra around for a long time. Calculus, whenever it was discovered, because like I mentioned earlier, I believe, and many other researchers believe, that mathematics is discovered rather than invented. When calculus was discovered, nobody had been doing it beforehand, and then now it's all of a sudden a thing. It is possible that prime number research could open up doorways to new versions of math that have never been done before. Some consequences for prime number research are that, like I said earlier, cybersecurity and encryption uses a lot of prime number randomness to secure different things online. If prime numbers were suddenly predictable, then that would have the potential to completely destroy the cybersecurity infrastructure, and there would need to be major changes and rearrangements in the technological world to account for that.
Okay. Brady, what was the most important research skill that you developed as a result of this process? And how might you apply it to your future endeavors?
I would say just all around. Sorry, can you repeat the question one more time?
What was the most important research skill that you developed as a result of this process? And how might you apply it to your future endeavors?
So I would say all around, just like perseverance in general, because as I mentioned in my presentation, I had struggles with finding an expert advisor early on. I reached out to several different people. I did talk with a few math teachers at Fairview High School. However, I wasn't able to find the resources that I needed to conduct my research, so I had to kind of just try to do everything on my own, and it took a long time to get to the function that I showed, but I would say just overall, regardless of circumstances, pushing through and making sure that I was able to get everything done that I needed to get done. And in the future, I can use this in college or in my potential careers to just remind myself that just because something's hard or just because I don't have the resources that I think I might need doesn't mean it's impossible.
Brady, thank you so much. All right, guys, the floor is open for general questions.
Yes.
So that constant you had, the A, the 1.25, all those numbers.
Yes.
Because you were talking about patterns and seeing patterns, is that closely related to some number that exists already?
I actually was very curious about this, and I wondered why the computer, the program that I used, which the program that I used was Desmo's graphing calculator. I was very curious why it gave me that specific number, and it's interesting. I just took a number that I knew was relevant in the math world, which is pi, and I just did the square root of the square root of the square root of pi, and it is almost exactly that number, which I think that would be, what would that be? The 8th root of pi is if I can go back to it, is pretty much that number, which I thought was fascinating. I don't know what the relevance of that is, but yeah.
Actually, I want to look at this page anyway. So they're all like right there at the top of your sign?
So yes, that is just the location that I decided to zoom in on it. The reason why the amplitude is what it is, why it stretches so much, is because in other parts on the function, the prime numbers go down, and so the sine wave basically just accounts for the variation in, right. And one thing that you might notice is there's a little gap right there. That little tiny gap on the large graph of 1,000 prime numbers is that.
What number was that big jump? Do you remember? Out of curiosity.
I don't remember specifically. It's in the it's.
I mean, you're way on up there.
It looks like it's close to around 430, 440, something around there. I don't remember specifically what it was. I did know at one point, but I had forgotten.
There's other questions?
It's a little, can I make a comment? It's just a little scary to think about the cybersecurity effects of what this.
It is. I talked to Mr. Phillips about this project because I had been thinking about this from the beginning of the year, thinking about doing something with prime numbers, and he said that if I were to somehow figure out a way to predict prime numbers reliably, he said the government would shut me down. So
Or hire you, one of the other.
yeah, that's true.
You got really close to .9991.
Yeah, it's interesting because whenever you look at the first coefficient of determination, 0.9502 is pretty close as it is, but as you can see, I mean, it's not. There's definitely some variation that you don't get with the new one.
All right, Brady, thank you so much.